Okay, so today we're going to talk about 10-2, solving systems of equations using substitution. The word substitution means exactly what it means. You will be substituting an equation into another equation. Remember, with our systems of equations, we always got out two equations, something like this. Okay? And what you would want to do in this case is you would want to take this equation and substitute it into this equation. Now, what's going to happen is you're going to end up solving for one variable. After you find the one variable, you can go ahead and find the other variable. Doesn't matter which variable you are solving for first, no. But substitution is a good way to do it, especially when you don't have a calculator and where you have to graph those two equations to solve your solution. Okay? It says when equations for lines in a system are in y equals mx plus b form, a method of solving called substitution can be very efficient. Example 1 illustrates this method. Example 1 says, solve the system y equals 7x plus 25 and y equals a negative 5x minus 11 using substitution. Now remember, our solution always comes out to be an x and y coordinate. So when you find your x, you have to go back and find your y. Okay? When the two equations are set up like this is pretty easy. Okay? So what I'm going to do is I'm going to take this equation, and wherever I see y in my first equation, I'm going to substitute y for a negative 5x minus 11, because that's what it says y equals here. Y equals a negative 5x minus 11. So wherever I see a y, right here, I am going to plug in a negative 5x minus 11. So what I'm going to do is I'm going to rewrite the first equation. Well, it says y. Well, y is now a negative 5x minus 11. So I write a negative 5x minus 11 equals 7x plus 25. Notice how I just rewrote it. This y now becomes this right here. Okay? Now, as you can see, I have an equation that's just in terms of x. So it looks like a basic algebra problem that we've done a long, long time ago. I got to get my x's together. I got to get my regular numbers together. So what I'm going to do here is I'm going to add 5x. Whatever I do to one side, I do to the other side. My 5x's add out, leaves me with the negative 11. And 7x plus 5x equals 12x. And I have to bring my 25 down with it. Okay? Now, I got to get my 25 over to the other side. The inverse of adding 25, subtracting 25. Now this algebra should be easy for you. That's why we worked on it for so long, semester 1, is so you wouldn't make the routine mistakes in algebra. A negative 11 minus 25 is giving me a negative 36. Believe it or not, a lot of people make mistakes on simple mathematics. The inverse of multiplying by 12, dividing by 12. So x equals a negative 36 divided by 12 is a negative 3. So I'm halfway there to my solution. I know x is a negative 3. But how do I find y? To find y, I let x now equal a negative 3 in one of those equations. So I'm just going to use the first equation right here. Y equals 7 times, what's x? X is now a negative 3 plus 25. So now that I know x, I'm going to now be able to find my y. 7 times a negative 3 is a negative 21. Plus 25 is now 4. So x is a negative 3. Y equals 4. This is your solution. This is where these two equations, if you were to graph it on your calculator, this is where these two equations would intersect at. Okay? At a negative 3, 4. This is one way to use without having to use a calculator and graphing your equations. Quiz yourself. Check that negative 3, 4 is a solution to y equals a negative 5x minus 11. Okay, this was the second equation. And we just checked it for the first equation, right? We did it and got our answer. So we need to see, or you can see if it works for your second equation. Because remember, it's supposed to work for both of them. So which means no matter what, if I would have chose the first equation or the second equation, I'm still going to be able to find out that negative 3, 4 was my solution. So let's see if it works. This is my x, this is my y. So y is now 4 equals a negative 5 times x. X is now a negative 3 minus 11. Well, negative 5 times a negative 3 is a positive 15. Minus 11, does 4 equal 4? Yes. So now you can see that no matter which equation you use, whatever you put in for your x, you're going to get out your y value. So it does not matter which equation you use. I just used the top one in that case. Let's get to some real-world problems. It says the Rapid Taxi Cab charges $2.15 for a taxi ride, plus 20 cents for each 1/10 mile traveled. A competitor, Carl Cabs, charges $1.50 for a taxi ride, plus 25 cents for each 1/10 mile traveled. So in this case, our x is going to be our 1/10 mile traveled. So I'm going to let x equal the number of 1/10 miles traveled. Okay? Y is going to equal total cost of the ride. Okay? So, let's set up an equation for the taxi company, the Rapid Taxi Company. So, my system's going to be y equals, he charges $2.15 automatically. Okay? So $2.15 just for getting in the car. You didn't even go anywhere. You sat your hind end in the car and he charged you $2.15. Plus, he's going to add on 20 cents for each 1/10 mile. So 20 cents is 0.2, right? Or you could put the 0 on there. You wouldn't have to. And then times 1/10 mile traveled. Well, how many 1/10 miles did we travel? We don't know. That is our x. Okay. Now let's make one for Carl Cabs. Carl Cabs charges $1.50 for a taxi ride, just as you sit in it. So boom, as soon as he flips the meter, it's $1.50. Plus, he is going to charge you 25 cents for each 1/10 mile. Okay? So, if you notice, Carl's Cab right at first only charges you $1.50. The Rapid Taxi Company's charging looks to be 65 cents more just for sitting in the cab. Okay? We're going to find a break-even point. And what that break-even point is going to do is it's going to tell us which cab company you want to pick if you are below that amount of distance to travel or if you are above that amount of distance to travel, that break-even point. So, two equations. It set up y and y, so this is perfect. So I'm just going to take this equation and I'm going to substitute it in for this y. So wherever I see a y up here, I'm going to actually write in 1.50 plus 0.25x. Okay? So y is 1.50 plus 0.25x equals, I'm just rewriting this equation, 2.15 plus 0.20x. Correct? Okay. Now, once again, we're back to our regular algebra. Get your x's to one side, get your y's to the other side. So, I'm going to move my x over here to the left. So the inverse of adding 0.20x is subtracting 0.20x. Whatever I do to one side, I do to the other side. Leaves me with 1.50 plus 0.05x. Be careful with your decimals, people. Be careful with your decimals. Okay, equals 2.15 now, because those will add out. Okay, now, I need to move my $1.50 over to the right. So the inverse of adding $1.50 is subtracting $1.50. Whatever I do to one side, I do to the other side. Leaves me with 0.05x is equal to, okay, $2.15 minus $1.50 is, as we said kind of before, 65 cents. Now, you have to divide by 0.05. So x equals 0.65 divided by 0.05. X is going to equal 13. Okay? Now, we got part of our answer right now. My x is 13. I still have to find my y. Well, either equation, it doesn't matter. I'm just going to let's put it into the second one just to show you that it's going to work. So, y equals $1.50, because you have to have an x and y as your answer, plus 0.25 times, what's x now? X is now 13. 0.25 times 13 is $3.25. $3.25 plus $1.50 is $4.75. So, what's that saying? 13 comma $4.75. What's that saying? Like I said, you get an answer, but what does that say? Well, my x is the number of 1/10 miles traveled. Okay? So if you traveled 13 1/10 of a mile, you actually rode 1.3 miles for $4.75. Okay? That's the break-even point. That's the break-even point. So, if you only had a ride for 1.3 miles, it doesn't matter which company you picked, okay? Carl's Cab or Rapid Taxis, okay, that price is going to be the same for both. Okay, that was the question. For what distance do the rides cost the same? Well, for a 13 1/10 of a mile, so at 1.3 miles, it costs $4.75 for both. Moving on to example 3. This is a good one. Kids racing against each other. Bart was so confident that he could run faster than his little sister that he bragged, "I can beat you in a 50-meter race. I am so sure that I'll give you a 10-meter head start." Bart could run at a speed of 4 meters per second, while his sister could run 3 meters per second. Could Bart catch up to his sister before the end of the race? Let's see. Okay. An equation for Bart. Y equals, I'm going to let X be number of seconds ran. I'm going to let Y equal total meters. Okay? So, Bart could run at a speed of 4 meters per second. So we're going to write 4 meters times, how long did he run? We don't know. That's my X. Okay? He could run 10 seconds, 20 seconds. We don't know how long they're going to run. Okay? His sister could run 3 meters per second. So we're going to make a new equation for her. Y equals 3x. But Bart is going to also give her a 10-meter head start. So she's already going to start 10 meters ahead of Bart. Okay? She is running slower, okay, than what Bart is, but she has a 10-meter head start. The question is, could Bart catch up to his sister before the end of the race? Well, let's find out. I'm going to take this equation and substitute it into this equation. Notice, it doesn't matter. A lot of times I just take the second one, plug it in the first one, vice versa. Okay? It all works the same. So wherever I see a y down here, I'm going to put in 4x. So, here's my y. It is now 4x is equal to 3x plus 10. Get my x's to the same side. Get my other numbers to the other side. I'm going to subtract 3x. Okay? When I subtract 3x, leaves me with 1x is equal to 10. So x is now 10. That's half of my solution. Okay? Let's find our y. Well, our y is pretty easy. All I have to do is plug it back into this equation. So y equals 4 times, what's 10? Okay? 4 times 10 is 40. Okay? So at 40 meters, Bart and his sister are what? They are at the same distance. They're at the break-even point. Okay? They both ran at 10 seconds, 40 meters. Okay? Everyone agree? Let's check out his sister's equation. Y equals 3 times x is now 10 plus 10. Okay? Y equals 40. So yes, his sister at 10 seconds is also 40. So, this is the break-even point. Could Bart catch his sister before the end of the race? Yes. Why could Bart catch his sister before the end of the race? Well, he caught her at 40 meters. That means, yes, he will catch her and win the race. A fun example to show you how to use substitution method. Have a great day. We'll see you tomorrow.